In this video we're going to be looking at hypothesis testing. Firstly, we're going to be looking at what is a hypothesis test, and secondly what the level of significance is of a hypothesis test. So a hypothesis test is basically a way of testing whether a population parameter is accurate or not. And in order to do this, we have to state two hypotheses. So the two hypotheses that we have to state are firstly the null hypothesis, which is normally written as HO, and this is what we assume to be correct. So if I had a coin and the probability, well, we'd assume the probability of getting heads is 0.5, so that would be our null hypothesis. The alternative hypothesis is written as H1 and then a little colon. And this tells us about the value of the population parameter if our null hypothesis is found to be wrong. Let's try and form some hypotheses in the context of a question. So I've got a question here, or part of a question anyway. It says a die is being tested. It is suspected that it does not produce enough sixes. Well, if we're testing a dice, a six-sided dice, we can say that X is the number of rolls. Let's say it's rolled 30 times. So it is rolled 30. So when we're testing it, we're going to test the dice by rolling it 30 times. We can say that X is the number of sixes in 30 rolls. Now, we need to make our hypotheses. We need to say what our null hypothesis is. So this is what we assume to normally be correct. So our hypothesis is that the probability of rolling a 6 is a sixth. And our alternative hypothesis is reflected by what's in the question. So it says that it's suspected that it does not produce enough sixes. So the alternative hypothesis is that actually the probability of rolling a 6 is less than a sixth. Now, you don't just have alternative hypotheses that are less than. You could have different hypotheses. You could have a hypothesis that the probability is greater than a sixth. That would be reflected if the question was saying that the dice produces too many sixes, so it's loaded towards sixes. Or you could have another hypothesis where we'd say that the probability is not a sixth. That's where you think it's unfair, but you're not sure whether it's producing too many sixes or too few sixes. So you test it both sides. We will be looking at those in future videos. But now that we've looked at the null and alternative hypotheses, let's move on to what the significance level of a hypothesis test is. So when we are testing this dice, if I roll it 30 times, X could have a value of anywhere between 0 all the way up to 30. So I could get no sixes, or I could get 30 sixes, or any number in between. But for us to make a judgment, we need to think, what value do we say, or what number of sixes would say that this dice is not fair? So the idea is that certain values of X are unlikely under our hypotheses, our null hypotheses, and would be better explained by saying the probability is less than a sixth. So we can split up the value of X that we get when we do a test. So it can be values that have a small chance of happening under the null hypothesis, and this is called the critical region, and the other part is the other values, which are more likely under our null hypothesis, which is, remember, that X has a probability of 1/6 in this case, where we're rolling a dice 30 times to find how many sixes there are. Now, I've put small chance in quotation marks because we have to define what the small chance is. Normally, a small chance is that it happens 5% of the time or less, or sometimes it's 1% of the time, and we use those generally to see whether something is likely or very unlikely to happen. Now this is called the level of significance. So this percentage is called the level of significance, and it's normally got the notified by the Greek letter alpha. So alpha is your level of significance. So let's have a look at this on our dice example. Now I've calculated the cumulative probabilities of rolling a 6 in, well, up to the 9 or less. So the probability of, in 30 rolls, getting 0 or less, which is just 0, is 0.0042. So you can see that's very, very unlikely. The probability that x is less than or equal to 1, you'd get that 2.95% of the time. Again, that's a very low percentage. If you were to get 2 or less, that would be 10% of the time. So we're getting more and more likely. So if we were to have our significance level of, so if alpha equaled 1%, 0.01, then our critical region would be just 0, this one. This is the only one that's below 1% chance of happening, because getting a 1 or less happens 2.9% of the time. So that's likely enough for us to say, yes, this dice is not loaded. However, if it happens 0 times, if we don't get any 6s, we'd say, well, it's very unusual in 30 rolls to only get, well, to not get any 6s, because that only happens 0.4% of the time. If we were loosening our restrictions a bit and we said that the significance level was 5%, then the critical region would expand to include this value here as well, because this happens only 2.9% of the time, and we're rejecting anything that happens less than 5% of the time. So if you test something and the probability of it happening under the null hypothesis is less than 5%, then you can say that it's too unlikely for it to be actually the null hypothesis that's correct. What's happening here is more likely to be explained under the alternative hypothesis. Now, I hope that's given you a flavour of what hypothesis testing is. We'll be looking at this further in some more videos coming up.